Welcome everyone to today's FTCOE webinar on the forensic examination and comparison of plastic garbage bags. Today's presenter is Ted R. Schwartz, a lecturer at the Henry C. Lee College of Criminal Justice and Forensic Sciences, University of New Haven. So at this point, I'll go ahead and turn the presentation over to Ted. Thank you.
Well, thank you very much. And I am very honored to have been asked to present this webinar. And I'm very honored that anybody actually agreed to show up. So thank you all for being here. I don't really have a ton of time here, so I'm just going to get right into it. First of all, I would like to thank Mr. Keith Mancini from the Westchester County Forensic Lab, my old stomping grounds, for providing several of the really good photographs in this talk. So, as an introduction, the question is, why do we care about plastic bags? Well, first of all, they're present in many criminal cases. Could be homicides, could be anything where somebody wants to get rid of evidence. Could be drugs, could be so many things. Body parts, bodies, smaller bags such as shopping bags, can have weapons, drugs, and pretty much anything else you can think of. So here's an example of a body in a bag. And, the main question, obviously, or the main type of evidence that people will think about is what's inside. Obviously the body, bloody clothes, things like that can be very important. But in addition to that, what people have to realize is that it could be very important to know where that bag came from. So in other words, if there is a suspect or some other person of interest, and they have a box of bags or a roll of garbage bags in their possession, could the bag have come from that source? And that can provide some very important context to a forensic case. Throw your X out. I mean, to me, that could mean something different from what the average person thinks. I'm looking at the garbage bags here and thinking, what's inside of those? So, it's very important to make sure the evidence is important, what's inside, and even fingerprints on the outside and all that. But sometimes it's very important to know what is in the bag, or where the bag came from. So to fully understand the physical characteristics of plastic bags, one has to know the manufacturing process. It's so important to understand this so you can know what it is you're looking at when you actually do examine bags. A little time. First of all, most of these garbage bags are made of plastic known as polyethylene. Okay. They are typically made from pellets that can be from, pristine, brand new, newly made polyethylene, or many bags are made from recycled bags. So that, if it's a recycled bag, the pellets are melted down, the bag is melted down and formed into little pellets that are then used to make new bags. Okay. There can be other things inside or, in the chemical mix of the bag, dyes, pigments. And I just mentioned that for uh, black colored bags, the main pigment that's typically used is carbon black. And at the bottom of this slide is a representation of the polymerization of ethylene to polyethylene. So as far as the process, once the company or the factory has these pellets, they're placed into a large bin, and I have photographs and even a short video to show you of all these things. The pellets are basically remelted. So it's anywhere between 400 to 500 degrees Fahrenheit, 200 degrees or so Celsius. It's formed into a liquid. The liquid is passed through a ring-shaped die and mandrel, and is then extruded through holes in this die. As the liquid exits the die, it is cooled and hardened. And there is air that blows upwards through through the polyethylene that's coming out of the die to form a cylinder. And the cylinder can be quite large. This cylinder tube is eventually, it can rise up in the factory 2 or 3 or 4 stories high, depending on how large the bags are. But at the top, it is flattened again into sheet, a large sheet, which then comes back down over many rollers. And at that point, several different things can happen to it. One thing is that sometimes there's a blade that perforates the bag. And then sometimes that's all that happens and it's rolled onto a large roller. Sometimes those, after the perforation, there's a pulling mechanism that pulls the bags apart. And at some point, at least one seal has to be made, like a heat seal in the bag. It's either on the bottom or on the sides, and I'll show you when you would, you know, decide to do each. In some factories, instead of being sealed, it's just rolled onto a spool, and that spool can either be sold as is or sent to another factory for other, other processes. So this is a representation of what I just talked about, where you see on the bottom right here, this is where the resin hopper is where the pellets are going to be placed into. They then are heated in these tubes down here. And then they are so melted, and then they come out of this die here in the shape of a large cylinder that pressurized air is being pumped through. As I mentioned, it rises up, and at the top it starts flattening and then coming back down as a sheet. Upper left photograph is a die and mandrel. This is the part that the plastic comes out of. On the bottom right is a example of, you can see the very bottom of this plastic cylinder here. This is a further away shot of the cylinder of plastic. You'll notice that there are kind of barriers here that keep the cylinder to a certain diameter. Okay. Also of note, sometimes the die actually rotates very slowly. Just something to keep in mind. This is looking down from a higher portion in the factory down to the die here, so you can see how large this can be. I have a very short video that I want to play here that kind of illustrates the manufacturing process here. And I'm going to start it right about here. So these are the pellets of polyethylene. Um, they will be placed into the hopper. Here they're being sucked up. They are melted, and this is that wall of plastic. And one thing I want you to note is that plastic is wobbling a little bit. So notice the vibrations of that plastic. That becomes important in some of the characteristics that we see. Here's a sort of a close-up of that. This guy's just making believe he's doing something, I think. So then after it goes up, it comes down in sheets. Okay. This is a perforation machine that's putting, it's not cutting all the way through, but it's putting markings in the bag that they can then be torn apart. Okay, so that's I have a lot of videos I usually show, but obviously there's not enough time to do that here. So smaller bags, such as tall kitchen bags, drawstring bags, things like that, are sometimes the sheet of plastic is sometimes cut down the middle, and then both halves are cut into sections. And I have a photograph of this, but I'll just explain it, that the end with the fold is the bottom of the bag, and the sides are what gets sealed. Okay. I'll show you something that explains that a little better. So in these kind of bags, the seal lines are on the sides, not on the bottom. And if it is a drawstring bag, the ribbon is folded into the top end and sealed. Okay, so here on the left is a picture of the sheet of plastic as it's coming down, from the rollers being cut. The right side is just a close-up of that. So it's being cut in half, and this is a representation of that where here's the blade. Now, as far as where the seals would go, if this bag was supposed to be larger, like the full width of this sheet, the bags would be cut here. The sides would be the natural fold, and then the bottom of the bag would have to be sealed. Okay. Here in these smaller bags, since they're cut down the middle here, the natural fold is actually the bottom of the bag, and then the sides have to be sealed. Okay. This is an example of a yellow ribbon being placed into the top of the bag. This is going to be a drawstring bag. Then that top has to be folded over and sealed. And this is obviously not a yellow ribbon, but a blue ribbon, but it shows you that drawstring bag, and I'm sure we've all used these. And you can see, you might be able to make out a seal line right here. Okay. So that's pretty much what I'm going to say about the manufacturing. Now let's talk about what it is you actually see when you examine the plastic bags. Okay. So we know that there are class characteristics that are not unique. They are common to one or more other bags or other items. And then there are individual or randomly acquired characteristics that are unique and random. They can aid in establishing a direct link between two garbage bags. So it turns out in garbage bags, we can sometimes see evidence of these two types of characteristics. Mostly what we're going to see are the class characteristics. And once you start delving into, um, plastic garbage bags, you suddenly realize just how many class characteristics there are. And it's actually quite fascinating once you really start looking at it. So length and width, obviously, thickness, color, weight is something that I, I I don't know if I even recommend doing because only because when you get a question bag, many times there were things inside. There still may be residue or something that's gonna um, being different in a couple of things in the bag. So just be very careful about that. Um, Seal marks and the location of them, um, perforations if they're present, and markings from the perforation and or the cutting blade. And I will be showing you examples of all these things. In addition, you have, is the bag gusseted or does it have gussets, which is a pinching in of the bottom and making it a sort of flat bottom. Many bags have codes and symbols, manufacturing numbers um, on them, which can obviously be very important. The type of closure, is it a twist tie? Is it a drawstring? Is it a quick tie? I'll show you examples of those. Um, all the measurements that can be made of that closure. And then I say other. I mean, one more common bag nowadays are what's known as flex bags. So, if the question is a flex bag and the box of bags are not flex bags, that's an easy exclusion right there. And there are microscopic characteristics that you can examine. So we talked about the drawstring. You see it on the upper left. Many of your larger bags tend to be twist tie. So you have to twist the top of the bag, and then they usually come with these little ties that you can use. The quick ties are kind of common nowadays as well. They're sort of U-shaped at the top, and it makes it easy to tie them. So length and width is another thing that you have to be somewhat careful with because this is something else that can change. It can even be different. These can even be different within a box. And at the end of the talk, I'm going to show you some research that we did in our lab to kind of illustrate some of this stuff. So, just be careful with this as well. You could, make a false exclusion if you are not careful with this kind of thing. Um, Perforations, a lot of characteristics just with that. What do they look like? The total number across an edge, the distance between perforations, and just a note that if two bags were indeed connected, their perforations would line up to each other. So here we have a bag that has several perforations. So this distance between them is something you can measure, that the total number of them. As far as the seal lines, the your thinner bags or your more common bags tend to have one seal line. Your more heavy duty bags, like contractor bags, may have two or even three seal lines. So in all of them, the distance between the edge of the bag, and again, that might be the bottom, it might be the side, but the distance between that edge and the first seal line is called the skirt. Um, the number of seals. If it's double sealed, then that's a good class characteristic. The width of each seal, the distance between multiple seals, and the pattern within the seal. So here we have, these were contractor bags. So these are very heavy duty, but this distance between the edge and the first seal line is known as the skirt. Okay, so that's a distance that can be measured. Obviously, again, the width of these seal lines, the distance between these seal lines, and close-up image of that, you can see this pattern here. And as you may know, a sealing machine is basically fabric. So this is a fabric impression. You could even tell if there was a defect in the fabric. You might routinely see a hole or something in the bags in a certain area. This is a gusseted bag, again, pinching in of the towards the bottom of the bag. Good characteristic to say, hey, my question bag is a gusseted bag and the box you gave me is not. Okay, not the same. Chemical differences. Now, it's true that most of the bags are polyethylene, but there can be other components in there, especially if the bag is colored. There's different pigments and things that can be used, so there can be elemental differences. So, microvisible spectrophotometry to analyze the color if it is a colored bag. Fourier transform infrared spectrophotometry for organic analysis, pyrolysis, GCMS, and then the elemental analysis of your choice. Could be SEM-EDS, could be X-ray fluorescence, X-ray diffraction, etc. Are interesting to me as far as garbage bags go are the extrusion dye striation lines. So these are caused by deposits of solidified plastic and or undissolved pigment lodged between the lips of the dye. So the object that the plastic comes out of, there are tiny particles that get trapped in there. And they rub against the plastic. So when you see, and I'll show you examples of these. So you have to use transmitted light, which I'll show you. The darker areas you see, the bag is thicker. The thinner areas, the bag is, or the lighter areas, the bag is thinner. So it's in those areas where there were particles rubbing against the plastic as it came out of the dye. So if extrusion lines from two different bags match, it means that there is a very strong possibility that they were made on the same machine and in fact at about the same time. And I'll talk a little more about that. But this is actually two different bags on a light box. So this is transmitted light. And you can see this is the separation between the two bags. And you can see these extrusion lines matching from one bag to the other. Now, that is not unique. We're not saying that these two bags, just because of this, that these two bags were definitely connected to each other, but we know they were made on the same machine at about the same time. By the way, this in the bottom half here, you can see some of these wavy lines, and I'll talk a little bit more about that, but I believe that's due to the vibrating cylinder as it's coming out of the die. So again, best visualized by using transmitted light. A flat light box is the easiest technique. An old school technique back in the day was to just tape the bags up to an outside window and look at the lines in that way. A case was done in my lab before I even got there where that's what was done. Sometimes you have to black out the parts of the light away from the bag. so that the only thing you're looking at is the light shining through the bag. So sometimes you need like a light blocking material to help you visualize these. Um, so the reason that we can say that they're made on the same machine at around the same time is that the particles that get caught in the die are somewhat temporary. Some can eventually flow out and new ones can come in. And that changes the pattern. So there's a limited number of bags, and I wish I could tell you how many. I can't. Um, Something I want to look into at some point, but there's going to be a certain number of bags that have that same pattern, and then it starts changing. Okay. And I just mentioned that for those of you who may be more used to doing firearms or bullet comparisons, this is similar to what I would guess a subclass characteristic. Um, this is two different bags on a light box. We were lucky enough in our lab to have a very large, I think it was 5 or 6 feet long light box. So you're literally putting the light box inside the bag because you don't want to shine the light through both layers. You just want it to go through one layer of the bag. So you're shining putting the light box in the bag, and then you can, move the bag to another location. So you can try to line up the extrusion lines that way. Photography of this is sometimes very critical, especially if it is a very dark bag. Um, I had a case where you couldn't even see the extrusion lines until you left the shutter open on the camera for 30 seconds or a minute and then looked at the photograph. So the photography of this can be, a little tricky, but just make sure you're using a tripod. And again, if it's a very dark bag, you're going to have to keep that shutter open for a certain amount of time, and you can experiment with that. Again, I think I mentioned that in the smaller bags that were halved in the middle, the extrusion lines, you'll notice, run from side to side, not from top to bottom. Um, I had cases where I was hoping to see really good extrusion lines, and I didn't. Um, so this looks like you're looking at a piece of wood, and it's not. This is the characteristics that were observed in these bags on the light box, and I called it a wood-like pattern, and so sometimes it's a beautiful extrusion lines, and sometimes it's other patterns. This is bags that had sort of oval shaped patterns in it. You might also see some dark lines on here. Um, I'm not sure what these are. They may be due to the rollers in the manufacturing process. Uh, there's a newer type of bag that you may have used. This is called Force Flex. They're flex type bags, expandable bags that are actually very interesting because, again, the thinner portions or the lighter portions are thin parts of the bag, and the darker portions are thicker. So these are designed in like diamond shapes, and they're meant to, be able to stretch, but they won't break because of the fact that each diamond is enclosed in um, a regular thick piece of the bag itself. So those are the Force Flex bags, but a very cool design on the light box. Um, then there's randomly acquired characteristics. Now, these are mainly from the machine or from the process. Okay. and I'll go over. They can be very helpful, and in fact could perhaps tell you that two bags were in fact connected at one point if these characteristics run from one bag directly into the other. Okay. So kind of looks like we're at a zoo or at a museum here. So there's stress marks or streaks, fish eyes, arrowheads, tiger stripes, scratches and gouges, and other. Highly scientific terms here, but show you some examples of these. These you'll see these two dark areas with lighter areas coming out from either side. Those are what are called fish eyes. And it's basically undissolved pigment. And, it causes a stretching around that to produce those fisheye type appearance. These are arrowheads, um, again, caused by the manufacturing process, but the locations of these are totally random in the process. And here's a close-up of one of these arrowheads going from one bag into the other. This is the separation between the two bags. Again, this is separation between the two bags is this light area here, and you can see the continuation of these patterns from one bag to the other. Okay, so that, given that the location and shape and look of these tiger stripes is random, this can show that these two bags were in fact connected. Just another example of that. This is not, I said bag separation. This is kind of, I don't think that's really where the bag separation is, but I just wanted to show it. Sometimes there's accidental characteristics on that between two consecutive bags. So if you pull bag apart in a certain way that allows for a physical match, you might be able to obtain a physical fit or a physical match. So in an ideal situation, this type of comparison will provide evidence that two items were at one time part of a single item. And I have this slide up here. Is this a physical fit or a physical match? Now, I have this on here because you have to be very, very careful. If we're going to say that these two bags were in fact joined together and this is a physical fit or a physical match, we better be absolutely sure. And I don't know if you can say that until you've looked at other bags in this box, and or from this company. It could be that there is a malfunctioning blade that would cause this to happen multiple times. So just be very careful if you're going to say that something is absolutely unique. You better be sure that it is. Also be aware that there could be other important evidence on the bag, such as DNA and fingerprints. We kind of talked about that. Trace evidence, drug residues, gunshot residue. Other evidence can be just as important as the bag itself. Just mentioning that there used to be, the FBI used to keep a database of bags called Pride. They don't anymore. So this was very helpful where if you had a bag and you wanted to know what the manufacturing, or where it was manufactured or the company, you could send them the bag or send them the class characteristics that you measured, and they had a database. Again, they don't keep that anymore, but I mentioned the FBI because they are still probably, the analysts that have had the most experience with bags. So certainly if you have questions, they are a great resource to go to. So as far as comparisons, always examine the question first, photograph, measure, and note all the class characteristics. and then you can move on to the knowns. For the knowns, thoroughly document the information on the box or packaging, and then carefully count the number of bags. That's important because if the box says that there's 30 bags and there's only 28, okay, we know that a couple bags were used. Okay, keep the bags in the same order as they were inside the box or package. Then analyze, the first bag as you did the question bag. If there are obvious differences in class characteristics between the Q and the known, then check at least one or two other bags in the box just to make sure that the knowns aren't different from each other. Okay, so I say assess any variation between the knowns by examining several of the other bags in the box or package. Okay. If all the class characteristics are similar between the Q and the K, and comparison of the extrusion lines should be conducted with transmitted light. If the extrusion lines are similar between the two, then look for the randomly acquired characteristics such as the arrowheads and things and see if any of them actually line up. You can do instrumental analysis at this point as well. If the extrusion lines do not match and all the analyzed knowns matched each other, then analysis can cease. Okay. If the extrusion lines and or other class characteristics are different between the various known bags, so if there is variation between the knowns, then a comparison should be conducted between the Q bag and all the different types of known bags in the box or roll. All right, so you want to make sure that, just because it didn't match one of the bags, that it also doesn't match any of the others. As far as conclusions, testimony, exclusion, if there are differences in class characteristics, then the Q could not have come from the same box or roll as the K. If there are significant differences, it may be possible to state that they are actually of different brands and or bag type. Okay, if there are no exclusionary differences in class characteristics and the extrusion lines match, it can be stated that the Q bag could have originated from the same box or roll as the K, or from another source of bags containing all these same characteristics. Also add, as I mentioned before, that this shows that the bags were made on the same machine at around the same period of time, or if you want to use the newer terminology, that this shows extremely strong support for the proposition that the items originated from the same machine at around the same period of time. If there are no exclusionary differences in class characteristics and extrusion lines do not match between the Q and any of the known bags, it may be possible to state that the bags are the same brand, but that they could not have originated from the same roll or box as the known. If class characteristics match and a physical fit can be established, or if those randomly acquired characteristics carry over from a question bag to a known bag, it can be concluded that the two bags were at one time connected, or again, more modernly, that there is strong support for the proposition that the two bags were at one time connected. Okay. I was asked to mention some research, and I'm just going to quickly talk about a project that I did with a fellow analyst from Westchester County, Jamie LaCausey, where we looked at these changes in the plastic bags. So we wanted to establish whether or not the plastic bags within a box have the same class characteristics, and also do dimensions of the plastic bags change after the addition of putting weight on the inside, and do they change after they were exposed to sun and rain and actually even burial. So this is a picture of just showing all the different bags we use. We use expensive bags, contractor bags. We use cheap bags from the local dollar store and a few other bags in between. So something, again, very important, the variation of class characteristics can occur even within a single box of plastic bags. What we found was that the cheaper bags, i.e. from the dollar store, had greater variation. And in fact, the length varied sometimes by as much as 4 centimeters. Um, Other bags within some box and rolls also varied, but quite that bad usually. As far as adding weight, it's not hard to believe that adding weight can change the dimensions of the bag, right? The flex bags, as you might guess, stretched out the most because they're designed to, sometimes by as much as 2.5 centimeters. Now, this was just based on 20 pounds. So we put 20 pounds in the bag. Um, and here you can see these are not flex bags, but you can see in these cheap bags that there were actually stretch marks that were observable. Um, these were bags left out in the elements and buried. Some were left out in the elements, some were buried for 4 months. Um, and this was something interesting to me. The length and width of both the thicker and thinner bags decreased slightly when the bags were left outdoors and or were buried. Typically less than about a centimeter or so, but they actually shrunk a little bit, which I was not really expecting. Um, the summary is it is important to take into account the history of the question bags, since added weight, exposure, etc., can cause changes to some class characteristics. Since there can be differences even within a box, it is important to examine as many known bags as possible to assess variation. And this may also involve, and I would recommend this, purchasing other boxes of the same brand to assess. Obviously, you go to a different place to buy it. It's probably made at a different time, and you can see variations of the same brand from different lots. That's very important to do. And that wraps up my presentation. If I could just spend a second or two, I'm just going to put these references up for a second or two so that you can, if you decide to watch the recorded version of this, you can go back. I have about 20 of these. You can go back and pause on these slides and get the references. And that is my talk.
Well, thank you very much, Ted. Hello, everyone. I am John Grasso with the Forensic Technology Center of Excellence. That was an excellent presentation. Thank you. We will now move into the question and answer period. And there's a lot of them, Ted. So the first one is, have you ever seen dye striation lines on stretch or flex plastic bags?
Um, I haven't, and I think it's because the pattern inside those flex bags are so loud, so convoluted that it is hard to see. There may be ways of doing it. I just haven't been able to figure out how.
Okay, our next question. Have you tested using Photoshop to aid in bringing out the extrusion lines?
Um, I haven't, but I'm sure that would be something very beneficial. Yes. I'm sure that would work, change the contrast or the brightness, and I'm sure that would help in bringing out the lines. Yes.
And our next question, can you tell us a little more about the physical match of a question bag and a reference sample? Is
Yeah, if it has to be, I don't know, sort of more of a violent tear or ripping apart of two bags to the point where it's not just along the perforations where the tear or break is. Um, so if somebody violently tears it and it's beyond where the perforations are and those line up, um, that's what I would call a physical fit or a physical match. Um, that picture I showed in my presentation might very well be a physical match or a physical fit, but Because it was kind of right along the perforations, I would need to assess that it wasn't from some malfunction of the blade or the, manufacturing process. So,
And our next question, what is the difference between stress lines and tiger stripes?
um, they might actually be the same thing. The tiger stripes, um, that they're I showed you a picture of the waviness within the bags. Um, and to me, if that's produced by the vibrating cylinder of plastic, you know, you could call it a stress mark as well. Um, there could be stress marks also from perhaps the pulling apart mechanism of the bags, that are maybe somewhat different from the tiger stripes, but I haven't really seen um, that much. So yeah, I don't know if that answered the question well, but
Yeah. Our next question, how can the physical match of two garbage bags, which have been extensively stretched and are heavily soiled with dirt and mud, be accurately conducted?
well, a lot of times, it um, if the question bag is so badly soiled and stretched and everything else, you may not be able to achieve a physical match. I mean, I think of it along the lines of sort of like a fabric physical match, where you're trying to physically match a torn piece of fabric back into a larger piece of fabric, and the ends are just not totally lining up because all the yarns are stretched out and that kind of thing. So so you're right in a way that there's sometimes where you just may not be able to establish a physical match. Doesn't mean that they weren't connected. It's just you're just physically not able to do it. Now, as far as dirt and debris and things like that, after all the other analysis is done, you can attempt to clean that material off, especially along those edges, and especially after fingerprints have done what they needed to do, and DNA might have done what they needed to do as well. And so that may assist in a physical fit or a physical match.
All right, thank you. A good question coming up on drawstrings. Are the drawstrings folded into the drawstring bags consecutively? And have you ever attempted to see if there is a match between the drawstring ends?
Um, I have not. So that's a question that I don't think I can answer. I don't know. That's a very good question to ask, and you know, you're really on the right track with thinking of all these possible characteristics that I told you that there's so many of them, and that's another one I hadn't even thought of. So yeah, sorry I can't answer that one.
No worries. Here's another one. Speaking of characteristics, can transparency be an individual characteristics is if such a device is available?
I'm not sure what they mean by transparency. Um, maybe that person could explain that a little better. I don't know
Okay.
if you want to jump to one and we can come back to that
Sure.
one.
And our next one, uh, do you do chemical comparisons after physical comparisons if needed?
Yes. Yes, you can.
Mm.
Yeah. And it's better if obviously it's better if the chemical comparisons are done um prior to things like fingerprint powder and other perhaps other chemical you know, enhancements that may have been done. Sometimes we don't have that luxury. So, there is a certain cleaning off of the bag that may have to be attempted before you do that. Yeah.
We had a couple questions regarding the conclusion scale or the that you use in your laboratory. Could you just go over what would the highest level of association or the term that you would use in your laboratory?
Well, I would actually say if I was able to show a true physical fit or physical match, or that there are these randomly acquired characteristics going directly from one bag to the other and everything else matches, I would say that those two bags were connected at one time. Now, having said that, sometimes it's hard to be able to take that other leap to say that they were from the exact same box of bags. And the reason I say that is because sometimes when I think it's one thing if it's a roll and they're and you have to literally tear off each bag, then you could say it was connected to that roll. But if it's a box and they're placed into the box individually in the factory, there can be bags from other machines. I remember one factory where there was a person standing in the middle and they had an open box and there was a machine to their right and a machine to their left, and they were putting bags from each machine into the same box. So that's when it's hard to know whether they were definitely from the same box or not. But, you know, I would say that they were connected at one time.
Right. And again, on conclusions, if there were similarities and differences in the extrusion lines, what conclusion would be given?
Um, Similarities and differences. I don't know. I mean, I think I would have to I would have to see that to know. Um, I mean, if there's a lot of similarities and only a few lines are different, um, I mean, I would have to think about it more and see it, but to me it sounds like it was probably made on the same machine, but perhaps at different times. So, the majority of the lines are matching, but some aren't. And as I said, these lines do change as time goes on. So it could be that they were made on the same machine, but at different times. But um, first of all, I haven't seen that, and I would really visually need um, to see an example of that.
And I think the one of the earlier viewers wrote back on the question that they had, and it was regarding light transparency of the plastic bag, so that it varies from bag to bag. What type of characteristic would that be?
Um, the amount of light that can get shown through the bag,
Yes.
that's a class characteristic. I had a case where um, I they were very dark bags, and I got a extrusion line match between the questioned and the known, and everything looked good. And we bought a couple of other boxes of bags, and they were darker. Um, so to me, if there's a difference in that, then it's an exclusion as to whether they were connected at one time. It's not necessarily an exclusion that they're from, the same brand. They may very well be, and it just might be that they were made at different times. One thing I'll add is that um, the manufacturers don't care what the bags look like, really. In all honesty, their quality control is, does the bag perform? So does it hold the proper weight that they are saying it should be able to hold? And if so, if the seal lines look a little different in one batch, or if they're a little darker or whatever, they don't really care. Because we're the only ones probably looking this closely at these bags to, so the average person doesn't care. They just want a bag to put their garbage in.
That makes sense. A couple questions on chemical analysis. What do you think is the best technique or instrument? And then another viewer is asking about FTIR. Can that be used to support your conclusion?
Oh yes, yes. I think I mentioned FTIR, and that was pretty much our go-to instrument, at least for mainly the organic components. You can maybe see some pigment. But if it was a colored bag, I would say to also include some elemental techniques such as SEMEDS or X-ray fluorescence, because the different colors could be from different elements, zinc or iron or what have you, that are, causing elemental differences. Yeah.
Thank you. And is there a value in cutting cross sections of the bag layer?
There can be. And one thing I didn't mention is that there are sometimes bags made um, where there's multiple sources of plastic being extruded and combined, to before it exits the die. So you could literally have sometimes 2 or 3 different layers, almost like a paint chip of plastic that make up the bag. So if that's the case, yes, it sometimes is helpful to take a cross section, and you might actually be able to see evidence of these different layers. It could also help you see maybe the pigment particles and things like that. So yes, that can all be helpful.
All right, well, thank you, Ted. Unfortunately, we do not have time for all of the audience's questions today, but feel free to reach out to the presenter for additional information, or if we did not have time for your question. Thank you so much for attending, and thank you to our presenter, Ted Schwartz, for being with us here today.
Thank you.
As you depart, we kindly ask that you take a minute or two to complete our post-event questionnaire. The link will be pasted in the chat and also appear as you exit the Zoom room. Your feedback helps us improve our outreach efforts and continue to provide the best experience possible. Thank you again for attending, and we hope everyone has a great day.